Now, when we move on to multi-digit addition or subtraction, we are going to need to think about place value and what it means to be adding different numbers and different place values together. So we're going to use a lot of base 10 blocks to illustrate what's happening here. So if I want to add 14 plus 23, I can first model the number 14 with 1 10 and 4 ones, and I can add to that 2 10s and 3 ones to illustrate 23. And what's happening if I were to add in vertical columns here, 4 plus, you might look at this and stacked and say, okay, 4 plus 3 is 7, 1 plus 2 is 3. But really what's happening here is I'm combining my ones, my 4 ones and 3 ones give me 7 ones, and my 1 10 and 2 10s give me 3 10s. So really how I should read this is instead 4 ones plus 3 ones gives me 7 ones, and 1 10 plus 2 10s gives me 3 10s. So that gives me a total of 3 10s and 7 ones, or 37. We can write this out expanded to first add the ones and then add the tens. That's something we can do. So we can say 4 plus 3 is 7, 1 10 plus 2 tens is 3 tens, or 30, and that gives me 37. The standard algorithm, however, more so isolates the columns. So we can also think about what happens when we have a value greater than 9 in our ones column or any column. And this is going to call for what we are going to refer to as regrouping. You may have heard phrases like carry or borrow or things like that when it comes to using an algorithm, but we really want to stick to this language of regrouping because that better emphasizes what is actually happening with our place values. So what we're doing first, if we want to expand this algorithm using regrouping, is I say 7 plus 8, 7 ones plus 8 ones is 15 ones. 15 ones is actually just the same thing as 1 10 and 5 ones. So that explains why I have 5 in my ones column and 1 in my my tens column. And then I add my tens together. So I say I have 3 tens here, so 30, 2 tens here, that makes 50, or 5 tens, or 50, and I add to that my 15 ones and 5 tens, giving me a total of 65. So if I wanted to add these values with the standard algorithm with regrouping, we need to make sure we're emphasizing this language of regrouping instead of carrying. So you might typically read this as 7 plus 8 is 15, drop the 5, carry the 1. Where are you carrying it? Why are you carrying it? Is it heavy? 1 plus 3 plus 2 is 6, 6 and 5, 65. Now, we can explain what regrouping means if we use base 10 blocks. So I can represent 37 with 3 10s and 7 ones, and I can represent 28 with 2 10s and 8 ones. And so when I go to add my ones column, I can add together my 7 ones and 8 ones. Now I can combine 2 of my ones from the 7 ones with the 8 ones from 28 to get a 10, and 5 ones remaining, 15 ones, or I can regroup this as 1 10 and 5 ones. And then when I go to find the sum, I'm going to add my 3 10s, my 2 10s, and my 1 10 that I got from adding my ones placed together, and I get a total of 6 10s. So I'll have 1, 2, 3, 4, 5, 6 10s and 5 ones because I already counted all my ones earlier. So when I say this with the standard algorithm, I could say, okay, 7 ones and 8 ones is 15 ones. 15 ones can be regrouped as 1 10 and 5 ones. So I put 1 in my tens column for my 1 10 and a 5 in my ones column. Now I add 1 10 plus 3 10s plus 2 10s gives me 6 10s, or 65 total. Okay, we can also add 3-digit numbers with regrouping. For example, 186 plus 127 would require 2 different regrouping steps. So first, we're going to have to add the ones and then regroup. So in this example, we have 6 ones and 7 ones. So 6 ones plus 7 ones is 13 ones. That's the same as 1 10 and 3 ones. We can illustrate this using our stacked chart. So what we would say is, okay, 6 ones plus 7 ones is 13 ones, which is 1 10 and 3 ones. And I can see this in my base 10 block representation if I model 186 with 100 block, 8 10s blocks, and 6 ones, 127 as 100 block, 2 10s blocks, and 7 ones. So I group together 10 of my ones to get 1 10 and 3 ones. When I move on to the next place value, when I want to group my 10s, I have 1 10 and 8 10s and 2 10s. So the 1 10 is coming from the one that I had from my regrouping of the ones place. I have 8 10s originating from 186, and I have 2 10s from 127. So I can regroup these 10 10s as 1 100. So instead of 11 10s, I have 1 100 and 1 10. So I could write this in my stacked format by saying, okay, 1 10 plus 8 10s plus 2 10s is 11 10s, which is 1 100 and 1 10. And then finally, when I go to add my hundreds place, I don't have any regrouping left to do. All I have to say is I have 1 100 from 186, 1 100 from 127, and 1 100 from regrouping. So I have 1 1 1 100, 3 100s. So I can write 3 100s. So my total is 313. We can also think about going from left to right. We don't have to always add our ones first, then our tens, then our hundreds. We could add our 100s first. So if I say 568 minus or plus 757, I can say, okay, at 500 and 700, that's 1200, which is the same thing as 1200. Then I might say my tens place. I have 6 in my tens place for the first number, 5 in the tens place for the second number. So that's 60 plus 50, that's 110, or 100 and 110. And then 8 plus 7, those are both ones. 8 ones plus 7 ones is 15 ones, or 110 and 5 ones. And then I need to sum all of these partial sums together. So I'll have 5 ones total, 2 tens, 3 hundreds, and 1,000, 1,325. We can also use something called the opposite change algorithm. So this is when we form a nice number by bringing one of the numbers closer to a 10 and then adjusting the addend so that it ends in 1 or more zeros. So this is maybe easier to explain through an example. So if I have 18 plus 25, I might say to myself, all right, I want to make this an addition problem without the need to regroup. I could say, okay, well, 18 is pretty close to 20, but I need 2 ones to get to 20. So I could instead make this problem 20 plus 23, because I would have to bring 2 of my ones from 25 to 18 and then add the rest of the 2 10s and 3 ones. So this would be 43. You could similarly say, okay, well, I could make this into something plus 30, I'm going to need 5 ones to get from 25 to 30. So if I take 5 away from 18, I have 13. 13 plus 30 is still 43. This would work either way.